Bom, B part 4, lecture 24th, rotation in the XY plane. We'll consider two cases, okay? The first one is passive rotation, change only on the basis. And second, active rotation, this rotate on the point. You see, they are different, okay? See this figure here, you have the same position vector, r identical to r prime. And this I rotate by an angle theta, only the position vector remains the same, but I rotate the axis, okay? This here is orthonormal basis. And so this I rotate the basis, you see? Ij, the red one, I prime, j prime, the blue one, see? So then I write, in this case, okay, r identical to r prime. Then I apply the dot product. You see, that's the same here, I prime dot I prime plus y prime. This is I dot j. You see, I multiply or apply in both sides the dot product between using the I prime. You see, I prime here, I prime there, I prime here, and I prime there. So then this vector r prime, this is identical to the vector r. You see, that's the vector r. Now, likewise, this I do the same. I take the dot product on both sides, okay? But here, I take the dot product of j prime. See, j prime here, j prime there, j prime and j prime. Now, it's easy to see, according to the orthonormal basis, this I prime dot I prime, okay? This leads, you see, a cosine of angle between I prime and I prime, which is 0. Then I obtain I prime here, and here is 0 because I prime I is normal, is perpendicular to j prime. So this will be 0 here. And I'll put here, you see, this one will be 1, this one will be 0. So then I represent x prime in terms of the cosine of this angle, okay? The angle between I prime and I, the red one, I prime and I, is the angle theta, you see? And the angle between I prime and j, just look here, I prime and j, is the angle is pi over 2 minus theta, you see? Likewise, you observe also the angles between j prime and I prime. J prime and I prime, attention now. You see, this is an angle which will be, in this case, you see I wrote over there. You see that just here. You see, just from here, I apply the cosine, okay, on both sides. I just copy from here, and I substitute cosine theta, cosine of pi over 2 minus theta. This is y prime, is in this case x cosine pi over 2 plus theta. Attention now, you see, the angle between, in this case, okay, I'll get, okay, this relationship quite easy. You see, just apply the definition of dot product. But I have this is orthonormal basis, so I use this just to lead to this relation. Okay, cosine pi over 2 phi theta is minus, you see, this over here is minus sine of theta. This one is cosine of theta. This one, this case, okay, pi over 2, this is theta, this is pi over 2 minus theta. This here is sine of theta. I just substitute and write here in terms of a matrix, okay? That's a matrix that relate the components of vector R, you see? And when I change the basis, this leads to different, okay, components. But the vector here is invariant. You see, this vector here is invariant because I rotate only the axis, you see? So this is called passive rotation, since you apply change of basis. Then I call this matrix here matrix A. You see, just copy from here. On the other hand, now I will derive the active rotation. Here, rotate the point. That's a difference here. Here, I rotate the point. You see? Consider the vector R, xi plus yj. This is a vector R. And the vector R prime. You see, here R coincides with R prime. Here, this point P, okay, it's rotate to point Q. You see, so they are different, but the magnitude of both are the same, which I call A, okay? Little a over here. So what this says? It says that the point P is rotating by theta. You see? The point P is rotating. This is rotated counterclockwise, okay? Because the zx, okay, is perpendicular to the board. So x, y, and z. Now it's quite easy. You see, observe that. See, x, the blue one, are the components of vector R applied at point P. You just a cosine. I call this angle here angle alpha. It's a sine. Now, on the other hand, R prime, you see, there's x prime with a cosine. Attention now, the angle between R prime and the x-axis is alpha plus theta, which I write over here. And the other component is I sine of alpha plus theta. It's quite clear and easy. You see, I just developed x prime. You see, the cosine of the sum of two angles. Okay, so this I can expand. That's a cosine alpha cosine theta minus a sine alpha sine theta. You see, but a cosine alpha is x, the blue one. Say, and a sine is y. So I just substitute the blue one, x and y, and I write there. You see, x cosine theta minus y sine theta. I do the same. Here is a y prime, okay? This is the sum, you see, of a sine alpha cosine theta, you see, plus a cosine and sine. Now I substitute the blue one. So I obtain x sine of theta plus y cosine of theta. Then I can express here in terms of matrix, okay? There's a square matrix. So x prime, y prime, you just cosine minus sine, sine and cosine. That multiplies this vector, okay? They are components of a vector x. This component of vector R prime, this component of vector x. Just to compare, you see this matrix in A? You see this matrix, here's A transpose. You see, you look at the here, if I transpose, I just got over there. So the relation between the components, attention now, here the point moves. Here the points remain fixed. I rotate the axis. Next, I will use the active rotation just to develop the rotation and angular momentum. I use this active over here. I use this matrix here, okay? that the point will be rotated. That's it.